Hi, ignore my tired eyes, but today I feel like I learned that a few of you had more trouble on Delta Math than I anticipated at first, and I want to make sure that you're getting the help that you need here. And I know some of you had questions that I might not have been able to answer individually, so I'm hoping this helps out. Totally optional, but here you go. This is what I've got. So one of the problems, the very first type of problem that you would have was one like this, where it says f, the twice differentiable function f is given by this, blah, 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 tells a lot about points of inflection, whatever. So I'm going to, one, just tell you first to make sure that you're really focusing on what graph this is. So if this is the graph of f, and I know I'm comparing the graph of f of 5, f prime of 5, and f double prime. Some of the important things in here, like the twice differentiable function, just means that there is a second derivative, that the function is f of x is continuous. But if this is twice differentiable, it means you can take the first derivative and take the second derivative, and they will both be continuous. So there is some important information. But in this particular problem, it says you can compare f of 5, f prime of 5, and f double prime. This is a really good test question. I've seen it on lots of things. I've seen it on the AP exam. Good chance that you'll see it very, very soon. Not necessarily this one, but you get the idea. And it might be a different graph, but this same idea. So if we are comparing f of 5, the very first thing is just what is the function value at 5? This is the graph of f. So f of 5 is just going to be 6. And that's it. So if I'm writing this on a piece of paper, I'm just writing, well, hold on, f of 5 is equal to 6. And that's it. Then the next thing that I'm going to be thinking is, okay, well, what's going on at x equals 5? So do you see at x equals 5? And I can even make a chart if I want to and think about what is going on with f, f prime, and f double prime. We did this a little bit in class today, depending on which group you were in, or whole class for first period. But I've got f, f prime, and f double prime, and x is equal to 5. And we just said that f of 5 was 6. But I can also say that f of 5, do you see how at x equals 5 that I've got a relative max on the graph of x? Or I'm sorry, on the graph of f of x? So if I have a relative max on the graph of f of x, that means the first derivative, f prime, the slope of the tangent, is going to be changing from positive to negative. And it's a nice smooth curve. So if f prime at x equals 5 is changing from positive to negative, and we know it's a nice smooth curve and the derivative exists, that means f prime of 5 is just going to be 0. And you could write more details and you could say, because there's a relative max, I know f prime is changing from positive to negative, but this is good because I'm comparing them. And then the next one, f double prime. Whenever you're looking at a graph of f and thinking about f double prime, this is all about concavities, just like it is when you go to the dentist. I hope not. Maybe you have no concavities. Anyway, f double prime. If f is going to be concave up or concave down. So I'm looking at the graph of f, and at x equals 5. Do you see how it looks like a frown? Oh no, so sad. So sad. So because concave down, so f double prime, I'm sorry, I'm going to go back up here. At x equals 5, f is concave down. So be really careful about that. Don't say f double prime is concave down, but f is concave down. Oop, there it is, which means f double prime is negative. I have no idea what negative value this would be. I just know it's negative, which means that I can put these in order and I can say f double prime of 5 is less than f prime of 5 is less than f of 5. Because these values go from negative to 0 to positive. Okay. That didn't go backwards on there, did it? It kind of looked like it for a second. Okay. We're good. Sorry, it looked funny on my end. Let's do another problem. I just found out I had a student view today. It's very exciting. Okay, in this one, the graph of f prime, the derivative of the function is shown below. So be really careful, but know that this is f prime. Determine the intervals which f of x is concave up. So this is where I'm thinking, okay, well, I'm given a graph of f prime. And I want to know where f is concave up. Well, I just said a second ago that f is concave up anywhere the second derivative is equal to 0. So f is concave up when f double prime is greater than 0. This is a really good justification for this. So if you notice, I'm not even actually looking at the graph yet. I don't know if you've noticed because you can't see where my eyes are, over there. Well, my eyes are right here, obviously. But I'm not even paying attention to the graph yet. I'm just like going through this reasoning before I even look at the graph at all. So f is concave up when f double prime is greater than 0. And so I'm going to say, when is f double prime greater than 0? Well, okay, I have a graph of f prime, so what does that mean? F double prime is greater than 0 when f prime, so this is where you really have to start thinking about connections. F double prime is the slope of f prime. Let me say that again. F double prime is the slope of f prime. So if I know f double prime is positive, think about the relationship between f and f prime. When the slope is positive, the original function is increasing. So that means if f double prime is positive, f prime is increasing. So I did all of this work first. So this would be my justification. So f is concave up when f double prime is greater than 0. F double prime is greater than 0 when f prime is increasing. It's really important to have both. And now I can look at my graph. And I'm only looking for the intervals where f prime is increasing. And so I would say from the interval from -4 to 0, from 2 to 4, and that's it. So, okay, so in this one from -4 to 0, and then from 2 to 4, because we're talking about where f prime is increasing. Let's do another. We did some of these in class, but I really like these ones. Okay, so here we've got the second derivative of a twice differentiable function. So again, a function is differentiable, meaning you can just take the derivative. It's therefore continuous, and it's shown below. The graph f double prime. So we're given a graph of f double prime this time. Okay, so I'm going to make a table just so I can kind of get an idea of what's going on. And you don't have to do this. It's just sorting out your thoughts right now. And I'm going to say x is on the interval from -4 to -2. So this is what I did. If you want to do this first and then try to see what you know. The graph of f double prime is what's given to me here. So from -4 to -2, x equals -4 to x equals -2. You can see here to here. So I'm going up, there we go, and stopping there. The graph of f double prime, what are all the things that you can say about it? So first of all, f double prime, is it positive or negative? Positive. And the reason why is because it's above the x-axis. So you can see from -4 to 2, f double prime is above the x-axis. Is it increasing or decreasing? Left to right, reading left to right, going up, increasing. Is this graph concave up or concave down? It looks like a frown. I'm going to say concave down. Okay, so we have this, and all of this I'm going to tell you is not actually that useful here, but we're going to go with it. So let's start with the f double prime is positive. If f double prime is positive, the second derivative tells you about f of x, the original function, whatever that is, concavity. So if f double prime is positive, would you be thinking concave up or concave down for f of x? When you're positive, you're usually happier, concave up. So f double prime is positive, which means f of x is concave up. This is not a justification, me saying this. I would actually have to write it down. I would say, because f double prime is positive, f of x is concave up in the interval. I'm just showing the chart just so you can make the connections as you're learning this. And then if f double prime is positive, what does that mean about f prime? So think about this. F double prime is the slope. Oop, there we go. F double prime is the slope of f prime. So if a slope is positive, what's that mean about f prime? It is increasing. So concave up for f F prime is increasing, F double prime is positive. And really, when we're given F double prime, we don't know too much more. So yeah, we're good here. So if you go through, it says it can be seen on the graph that F double prime, this is what we did originally. So when you're looking just at the graph, you're like, oh, F double prime is positive. I can see that it's increasing, and I can see that it's concave down. And then we go through, what are the other conclusions? Is F prime, we know it's increasing, and the reason why is because F double prime is positive. We know F is concave up because F double prime is positive. Okay, I'm actually, could I do a new problem? I might come back to this in a second, but that's a general idea. Now I'm going to do one more. Oh, it's giving me the same ones. I have to answer it real quick. Okay, so we said this was positive. We said that it was increasing and concave down. The graph of F would be, and so in this one, the only thing we know about it is it's concave up, and because F double prime is positive, and we know F prime would be increasing, and the reason why is F double prime is positive. Woo, we did it. Okay, now I'm going to do a new problem. Great, I want to do a new problem anyway. Yeah, okay, I am going to be able to do another one. So this one is the graph of F. So this is slightly different. So if you've got a graph of F, and I'm looking at 2 to 0, so X, F, F prime, F double prime. So I'm doing the same thing that I did before, but now I'm given a graph of F. So on the interval from -2 to 0, and I'm thinking, okay, well, what's going on with the graph of F? From -2 to 0, I can see that this graph is f of x going to be positive or negative? It's negative because it's below the x-axis. So just exactly what you see. The graph of f is negative. I can also see is from -2 to 0, is this increasing or decreasing? Is it f increasing or decreasing? Increasing. And then the last thing is this graph concave up or concave down? And I can see from -2 to 0 that the graph of f of x is concave up. It looks kind of like a smile. I mean, not a great one, but a smile nonetheless. Okay, and then if I want to say, well, okay, what about, does f being negative tell me anything? The function value being below the x-axis? Not really, but it's good to go through that process. Does that tell me anything about the slope? Does it tell me anything about the second derivative? Not so much. The fact that f is increasing, though, does. So as soon as we see f is increasing, what do I know about its slope? The slope of f. It's positive. Okay, and then the next one. So if I know, does that f prime being positive tell me about anything about f double prime? No, kind of stuck there. Okay, what about concave up? So if I know f is concave up, concavity, as soon as you're talking about the function f, you should immediately be connecting concavity to the second derivative. So if a function is concave up, so f of x is concave up like it is on the graph, then f double prime should be, what should it be? Positive. So f double prime is positive. And let's think about this. F double prime is the slope of f prime. That means f prime is going to be increasing. Ta-da! We did it. Okay, and then we'd go through and we'd have to say all these things. So from -2 to 0, we said this function was negative increasing concave up. So negative increasing concave up. So f prime, we said that it would be positive only. Oh, sorry. We said it was positive and increasing. So I'm looking at my chart. There it is. I don't know why I had to sing. So we know it's positive and increasing because F is we said positive and increasing, and the reason was because F, so we have to go back to that original one, was increasing and concave up. So I'm looking at this reasoning and I'm like, okay, wait, this one, I'm going backwards. Increasing went with concave up, the positive went with increasing, or positive went with increasing went with concave up, but it's weird because you look at your chart. I'm sorry, it's super late. By late, I mean 8:58, but I'm old and very tired, and I get up at like 4. Anyway, on the interval from -2 to 0, F double prime would be, and we just said this was positive only, and because F is concave up. So all of this, again, because I mixed my words up, is coming from this chart. And then I submit. Then I don't care even if I feel like I know this stuff so well, and I actually do feel like I know it really well, which I hope you would think that. I still get nervous for that green check. If I say the next problem, it's going to say, okay, just the graph of F prime. Okay, so here's one more. So this gives you a graph of F prime. So I'm still doing the same thing, X, F, F prime, F double prime. And then I'm thinking, it says, what can be made about the graphs of F, F prime, and F double prime on the interval from -3 to -1? So -3 to -1, -3 to -1, so here to here, that's nice. And it probably says something about point of inflection. You can see point of inflection is where f of x, or I'm sorry, not f of x, whatever graph we're talking about. It says the graph of f prime has points of inflection. Points of inflection occur when the graph, whatever graph, f prime in this case, changes concavity. Most of the time when we talk about changes in concavity, we talk about f of x, but here, this is fine to know this. It's really just telling us that the frown happens from here to here and then starts turning into a smile here, or concave down to concave up. You can see it changes here, concave up to concave down at x equals 3, -3. So in this one, it says from -3 to -1. So -3 to -1. I need to see, so from here to here. This is the graph of f prime. List all of the things you know about it. So is f prime from -3 to -1 positive or negative? Positive, below the x, or above the x-axis. Is f prime increasing or decreasing from -3 to -1? Increasing. Is f prime concave up or concave down? So when you're looking at that, does it look like a smile or a frown? A frown, so sad, concave down. Okay, so I know all these things, and I may or may not have to use all of them. But there's several things now that I can use. So if f prime is positive, or I could say the slope of f is positive, and you kind of notice that I'm ignoring this graph now. So I wrote down all these important pieces of information, and now I'm backing away from it so it doesn't confuse me here. If f prime is positive, the slope of f is positive, what does that mean about f? F is increasing. So far I've got this. And then I think, okay, well, if f prime is increasing, what does that mean about f double prime? So if f prime is increasing, that means f double prime is positive because f double prime is the slope of f prime. And as soon as I say the second derivative is positive, what do I know about the function f? I know the function f is concave up. Make sense? I'm hoping. I don't know. This is a video, so I can't hear you yet. But I'll probably put in a puzzle comment at the very end that you can say, yes, I understood it, or no, I didn't. Okay, let's do another. How about we did this one? We have 2 more things to do. Okay, here. What inferences can be made about f, f prime, and f double prime when x equals 2? So this one is at a very specific point. So we can still do the same thing where we're thinking about like, okay, x, f, f prime, f double prime. We're just thinking through this, the connections between them. But at x equals -2, what's happening? Well, I can see that this is a graph of f prime. So at x equals -2, I can see there's a relative minimum. So I'm just looking at the graph and it looks like relative minimum, like there it is, great, it's a relative minimum. What does that mean for f double prime? So if there's a relative minimum, let's think about it. What's happening to the slope of f prime? I'm hoping that you're thinking, okay, minimum, what would that be doing? And changing from negative to positive. So f double prime is changing from negative to positive. So this is what I have so far online. If f double prime is changing from negative to positive, another way I can think about that is f double prime is changing signs. As soon as f double prime is changing signs, that means f has a point of inflection at x equals -2. So if I go down here, I can see on f prime, it's going to ask me positive or negative. So at x equals -2, I can see that f prime of -2 is 3. Like it's just the function value here. So I'm going to say is positive. F prime, we said has a relative min. We can also infer that at x equals -2. And so I'm just going back up to where f, I'm going to say that f when x equals -2 has an inflection point. This is one that I'm going to do first. So a point of inflection, and we said f double prime changes from negative to positive. So think about negative to positive. That would be concave down to concave up. And in this one, do we know anything else? At x equals -2. F prime. So if this is graph of f prime, do you see how f prime is going to be, if we're saying f prime is positive right here, so above the x-axis, which I could have put that into, that means f of x is increasing. And so down here, I'm just going to say, oh, well, no horizontal tangent, because this one is going to be like, it's just going from positive to positive, and that's about it. So it's fine. Even right here, the slope of at x equals -2, or f prime, is 3. So still positive, nothing crazy going on. Furthermore, that we can state that f double prime is, do we know anything else when x equals -2? We said changing from negative to positive, that's also known as 0. So negative to positive. And again, I'm just looking at this thing and then filling in the blanks from there. We did okay, last thing. This one will be actually pretty fast because you did all of these before. Like you did a lot of this in your notes, and then on that circuit, you did a lot of these too. So given this function, find all the intervals which f is concave down. So what you're going to do here is you would have to take the first derivative. So find f prime, multiply by 6, subtract by 1, all the stuff for the power rule. Do the same thing then, take the second derivative. Find the zeros, make a chart, figure out where the derivative is equal to 0, so that where the second derivative is equal to 0. So that whole sign chart that we did, and I feel like that's the one that you kind of did the most, that's what you would do here. If I want to know the intervals where f is concave down, I would have to find where f double prime is negative. If you wanted to find concave up, f double prime would have to be positive. And if there was a point of inflection on f double prime changes signs. Okay, thanks so much. That's all I've got right now. Thank you. Have a good night, morning, whenever you're watching this. Bye.